Fraction notation includes some definitions that we're going to utilize. So I'm going to start by talking about what fraction notation is. So we've got a fraction, and a fraction has two parts to it. It has a numerator and a denominator. So the number in the top of the fraction is called the numerator, and the number on the bottom is called the denominator. Now, a fraction is a division problem. So we can think of this also as division. So this is most definitely a division problem. And any number that can be written as a fraction without decimals, a fraction without decimals is a rational number. Let's first talk about factors and prime factorization of numbers. We've got natural numbers. Natural numbers are often referred to as counting numbers. So when we learn to count as young children, we learn to start with 1, and then 2, and then 3, 4, and so on and so forth. Factorization are numbers that multiply together to make a product. So if I want to find all the factors of, let's say, 18. The numbers that multiply to be 18, and sometimes I'll come off to the side and I'll do this. I'll say 1 times 18 is 18. 2 goes into 18 evenly, so goes into 18 9 times. 2 times 9. 2 and 9 are factors of 18. 3 goes into 18 6 times. 3 times 6 is 18. 4 does not go into 18 evenly. 5 does not go into 18 evenly, but 6 does. 6 is already listed, so that tells me that I have all of my factors. So the factors of 18 are 1, 2, 3, 6, 9, and 18. And you'll see if we work our way outside, 1 times 18, 2 times 9, and 3 times 6. That tells me I've got all of my factors of 18. We're going to write fractions in the form of factors so that we can simplify our fractions. So we're going to be using this definition of factors quite a bit. And how we find factors is using prime factors. So we're going to break numbers down into their prime factorization. So it's important for us to know what prime means. So prime is another definition. Prime numbers are numbers that are natural. So a natural number, which means starting at 1, 2, 3, 4, 5, 6. So any of those counting numbers, any of those natural numbers that have, so a natural number that has exactly, no more and no less, exactly 2 unique or different factors. So exactly 2 different factors. 18 would not count because 18 has 1, 2, 3, 4, 5, 6 factors. So 18 is not a prime number. When it's not a prime number, it's called a composite number. So I'm going to say a composite number, and I'm going to quite simply say not a prime number. So if it is not prime, it is a composite number. Again, it needs to be a natural number to be a composite number. We're not talking about negative numbers yet. We're not talking about 0. We're just talking about numbers that are counting numbers. So let's try and find our prime factors of 18. What I'm going to do first before I start finding my prime numbers is or my prime factors, I'm going to start listing all the counting numbers, and let's talk a little bit more about these and make sure that we can identify prime numbers. So I'm going to list as many as I can here. Oh, I was able to get to 23. And I move this over just a little bit. 23 is good. But this keeps going forever and ever and ever. 1 is not a prime number because the factors of 1 are just 1. And remember, we need to have at least 2 different, exactly 2 factors. 1 only has 1 factor. 2 is 1 times 2. That's exactly 2 different factors. 2 is a prime number. 3 is 1 times 3. That's exactly 2 different factors. 4 is 1 times 4, and also 2 times 2. That would be 1, 2, and 4. That's 3 different factors. 4 is not a prime number. It is composite. 5 is a prime number because its only 2 factors are 1 and 5. 7 is a prime number because its only 2 factors are 1 and 7. Exactly 2 factors would not include 9 because 9 is 1, 3, and 9. Notice how I can skip over every even number here on after because even numbers are all divisible by 2. So they have more than 2 different factors. So now I'm looking at the odd numbers to see which odd numbers are going to be prime. 11 is a prime number. 13 is a prime number. 17 is a prime number. 19 is a prime number. And then 23 is a prime number, and so on and so forth. Prime numbers are very, very helpful when we are trying to prime factor. So I'm going to take 18. Let's continue to use 18, and we're going to prime factor 18. When I want to prime factor a number, I take that number and I put it in a box that looks like an L. And I'm going to start with the first prime number, which is 2. And I'm going to ask, does 2 go into 18 evenly? 2 does indeed go into 18 evenly. 2 goes into 18 9 times. So this is a way to divide. Then I'm going to ask, is 9 a prime number? If it is not a prime number, I'm going to put a box around it because I'm going to continue dividing. 9 is a composite number, so I put a box around it, and I continue with 2. Does 2 go into 9 evenly? 2 does not go into 9 evenly, so I move to the next prime number. So my prime numbers are 2, 3, 5, 7, 11, 13, so on and so forth. We've exhausted 2, so now we're moving on to 3. 3 goes into 9 3 times. I look at 3 right here, and I say, is it a prime number? If it's a prime number, then I'm done. If it's not a prime number, I put a box around it, and I continue dividing. 3 is a prime number, therefore, my prime factorization for 18 is 2 times 3 times 3. These are all prime numbers. 2 is prime, 3 is prime, and 4 is prime. And factors means that we're multiplying numbers together. So we're multiplying these numbers together, which makes 2, 3, and 3 factors that have a product of 18. So there's our prime factorization. So this right here is our prime factorization of 18. 2 times 3 times 3, prime factorization of 18.